Have you ever wondered if life could exist on other planets? This question has sparked the imaginations of countless individuals throughout history, from science fiction writers to real-world scientists. We've always been captivated by the vast, untamed expanses of the cosmos and the mysteries they hold. Could we as a species ever call another world home? The concept of terraforming, the process of modifying a planet's environment to make it habitable for life as we know it, has been proposed as a potential answer to this question. This isn't just the stuff of science fiction, though it's certainly played a significant role in such narratives. There's real, ongoing scientific research exploring the feasibility of terraforming. We're talking about transforming desolate, alien landscapes into living, breathing ecosystems. It's an exciting, daunting proposition. But how does terraforming work? Let's dive into the process. Terraforming, in essence, is the process of changing the environment of a planet to make it habitable for life as we know it. Picture, if you will, a barren, inhospitable planet. The surface is dry and cracked. The atmosphere is thin or perhaps non-existent, and the temperature is either scorching hot or freezing cold. Now, imagine transforming this planet into a lush green world, teeming with life, similar to our own Earth. That's what terraforming is all about. Let's break it down. Terraforming is a theoretical process, a grandiose vision that lies at the intersection of astronomy, biology, and engineering. It's all about creating conditions on a planet that can support life as we know it. But what exactly does life as we know it need? First and foremost, water. Life on Earth began in water, and it remains a vital ingredient for all known forms of life. Without water, life as we know it simply cannot exist. Therefore, any terraforming effort would need to either find or create significant amounts of water. Next up, an atmosphere. This isn't just about having air to breathe. An atmosphere provides protection from solar radiation, helps regulate temperature, and is a key component in the water cycle. Without an atmosphere, water on the surface would either freeze solid or evaporate away. And speaking of temperature, that's another essential element. Life as we know it requires a certain range of temperatures. Too hot and water boils away. Too cold and it freezes solid. The challenge here is to strike a balance, to create a Goldilocks zone where the temperature is just right. So, to sum it up, terraforming is the process of transforming a planet to make it more Earth-like, with the key goals being to establish water, create an atmosphere, and regulate temperature. It's a daunting task, to say the least, and one that would require an incredible amount of resources and technological advancement. Now that we know the basics, let's explore the steps of terraforming. The first step in terraforming a planet is building a suitable atmosphere. It's almost like baking a cake, except instead of flour and sugar, we're using gases and life forms. So how do we go about creating this atmospheric concoction? Well, scientists have proposed multiple methods, each as fascinating as the next. One such method involves releasing trapped gases. Picture a barren planet, devoid of life, yet filled with potential. Beneath its rugged surface, it holds a treasure trove of gases like carbon dioxide, nitrogen, and in some cases, even water vapor. By employing various techniques, such as heating the planet's surface or striking it with comets, we could potentially unlock these trapped gases, allowing them to rise and form an atmosphere. Now you may be wondering, isn't carbon dioxide harmful? Yes, in large quantities it can be. However, it's also essential for life as we know it. You see, carbon dioxide is like the yeast in our atmospheric cake. It's a greenhouse gas that can help warm the planet, making it more hospitable for life. But we don't just need warmth, we also need oxygen. That's where the second method comes into play, introducing life forms like algae and plants. These tiny green warriors are experts at converting carbon dioxide into oxygen, a process known as photosynthesis. By cultivating these life forms on the planet, we could gradually increase the oxygen level, making the atmosphere more breathable for future settlers. And it's not just about oxygen. These plants and algae can also help in creating a balanced ecosystem, where various gases are kept in check and life-sustaining cycles are established. It's a slow process, no doubt. We're talking about centuries, if not millennia. But every great journey begins with a single step, and in the journey of terraforming, that first step is to build an atmosphere. Once we have a breathable atmosphere, the next step is to introduce water. But that's a story for another scene. Until then, let's revel in the marvel of our atmospheric cake, a testament to human ingenuity and the endless possibilities of life beyond Earth. Water is the elixir of life. Without it, life as we know it can't exist. This phrase is no exaggeration. Water is a fundamental building block for life as we understand it. It's not just about quenching thirst, it's about regulating temperatures, facilitating chemical reactions, and providing a habitat for countless organisms. So, how do we introduce this precious liquid to a terraformed planet? Well, it's not as simple as filling up a massive spaceship with water and pouring it onto the planet's surface. It's a complex process that requires innovative solutions and ingenious engineering. One method is to import water from Earth. However, this is not the most feasible option, considering the sheer volume required and the astronomical costs associated with space travel. It's like trying to fill an Olympic-sized swimming pool with a teaspoon. A more promising method is to extract water from the planet itself. Many celestial bodies, including our Moon and Mars, have significant ice deposits. These ice reserves could be melted down to provide a source of water, but melting ice on a large scale requires energy, a lot of it. This is where solar power could play a crucial role. Another approach might be to create water through chemical reactions. It sounds like science fiction, but it's entirely possible. Hydrogen and oxygen, the two components of water, are abundant in the universe. If we can find a way to combine them efficiently, we could literally make water out of thin air. But introducing water is just one piece of the puzzle. We also need to ensure that it remains in liquid form, which brings us to temperature regulation, another essential aspect of terraforming. With water and a breathable atmosphere, we're getting closer to a habitable planet, but there's still more to do. We've built our atmosphere, introduced water, and we're inching closer to our goal. Yet the journey of terraforming is far from over. It's a marvel of human ingenuity, a testament to our species' unquenchable thirst for exploration and discovery. The final step in terraforming a planet is regulating its temperature. In our quest to make a planet habitable, once we've built the atmosphere and introduced water, the next crucial step is to strike a balance with the planet's temperature. It's a delicate dance, aiming for a climate that's not too hot, not too cold, but just right for life as we know it to thrive. One proposed method to regulate a planet's temperature is the use of greenhouse gases. Sounds familiar? That's because we're already experiencing the effects of these gases right here on Earth. Greenhouse gases like carbon dioxide and methane absorb and radiate heat. In controlled amounts, they can help trap heat and warm a planet that's too cold. But what if the planet is too hot? That's where giant space mirrors come into the picture. Yes, you heard it right, giant mirrors. The idea is to position these mirrors in space to reflect sunlight away from the planet, thereby cooling it down. These mirrors would act as a sort of sunshade, reducing the amount of sunlight that reaches the planet's surface. Now, these methods are still largely theoretical. We're yet to test them on a large scale, and there are plenty of challenges to overcome. For instance, producing the right amount of greenhouse gases without triggering a runaway greenhouse effect is a delicate balancing act. And the construction and deployment of space mirrors? That's an engineering challenge of astronomical proportions. But despite these challenges, the idea of regulating a planet's temperature to make it suitable for life is fascinating. It's a testament to human ingenuity and our relentless pursuit of knowledge. And who knows? Maybe one day we'll look up at the night sky and see not just barren planets, but potential new homes. With these steps, we could theoretically transform a barren planet into a new home for life. Terraforming is still largely theoretical, but it represents a fascinating possibility for the future. As we stand on the brink of this new frontier, we grapple with complex challenges and ethical considerations. The endeavor to terraform a planet is not just about science, it's about the very essence of humanity. Our ability to adapt, to dream, and to push the boundaries of what is possible. The potential benefits are immense. Imagine a second Earth, a new home for our species and countless others, but the risks are equally daunting. Could we unintentionally disrupt an alien ecosystem? What if our attempts to transform a planet backfire, creating an inhospitable wasteland? Ongoing research is striving to answer these questions. Scientists and ethicists alike are working tirelessly to understand the implications of this monumental task. As we continue to explore the cosmos, the possibility of terraforming might become a reality. Until then, the stars are the limit.